Okay, 19. If xy is a solution to the system of equations above, minus 3x plus 4y equals 20, 6x plus 3y equals 15, what's the value of x? Okay, so is there a quick way I could combine these? Adding, subtracting, no, I don't see that right away. So what I might do here is just go to eliminate. So I'm going to multiply the top equation by 2 to offset this 6x. So up above, that would now be minus 6x, 2 times minus 3x, plus 2 times 4y is plus 8y, plus 2 times 20 equals 40. So I'm just going to add the top equation with the bottom equation now. 6x minus 6x zeroes out. And then we get 8y plus 3y equals 11y. And that equals 40 plus 15, which is 55. Divide through by 11. Y equals 5. So what is x? Well, we're going to have to plug that back into one of the equations. So 6x plus 3 times y, which is 5, equals 15. So subtract 15 from both sides. 6x equals 0. X must equal 0. The correct answer for 19 is 0. But let's just double check that in the other equations. Minus 3 times 0 is 0, plus 4 times 5 equals 20. That checks. 6 times 0 is 0, plus 3 times 5 is 15 equals 15. That checks. That's the correct answer. X equals 0. Number 20. The mesosphere is the layer of Earth's atmosphere between 50 kilometers and 85 kilometers above the surface. At a distance of 50 kilometers, the temperature in the atmosphere is minus 5. Okay, so if we created kind of a graph here of height and temperature, we would have minus 5 for temperature on the x value for a height of 50 kilometers on the y value. At 80 kilometers, that's a y value of 80 kilometers, our temperature is minus 80, all in degrees Celsius. Okay? So between these 2 points, I can set up a linear equation. I can say m equals the changes in the y, 80 minus 50, divided by my changes in the x, which is minus 80 minus 5. Okay? So the slope works out to 30 divided by minus 80 plus 5 is minus 75. Okay? So basically, we can see that for every 30 meters or kilometers that we go up, the temperature goes down 75 degrees. So I might now look at this a couple different ways. I can see that's also equivalent to every 10 kilometers we go up, the temperature drops 25 degrees. They tell us in the problem, if we go up another 10 kilometers, the temperature in the mesosphere decreases by K degrees Celsius. What is the value of K? Well, if we went up by 10 kilometers, we should drop another 25 degrees. So, or decrease by K degrees is 25 degrees. K equals 25 degrees that we're decreasing by. There seems to be a curious problem here, though. Our mesosphere ends at 85 kilometers, and another 10 kilometers from 80 kilometers would take us to plus 90 kilometers, which might, according to the problem, be outside the mesosphere. So I'm not clear that the linear relationship would work because they only defined it in the mesosphere. So who knows? But if we assume that's the case, it looks like K is 25.